so let's pick up where we left off yesterday, and we'll look at example 3. Example 3 is different than the type of problems we did yesterday. It says simply sketch a triangle that has acute angle theta and find the other 5 trigonometric ratios for theta. So I have sine of theta, cosine, tangent, cosecant, secant, and cotangent. So I'm going to sketch a right triangle. Theta is the acute angle. And can somebody tell me how I can start to label the sides of the triangle? Hypotenuse is what? 7, because sine is opposite over hypotenuse. That means its opposite side is 3. Now I can use that information in order to find the adjacent side, correct? So there's an infinite number of triangles that will have these ratios. Instead of 7 and 3, you could have had 6 and 14, right? You have 0.3 and 0.7. And sine will still end up being 3 over 7. We're just constructing one triangle that would work. So I'm going to do a squared plus b squared is c squared, or 9 plus b squared is equal to 49. Subtract the 9, we get b squared is 40. 2 roots of 10. Good. So I know sine of theta is 3 over 7. Means cosecant is 7 over 3. Cosine. Two roots of 10 over 7. Secant, I would flip that. 7 over 2 roots of 10. Uh-oh. Can't have a square root in the denominator. 7 roots of 10 over 20. How about tangent? Three over 2 roots of 10. Can't have the root of 10 in the denominator, so multiply top and bottom by the root of 10. 3 roots of 10 over 20. I would flip that to find cotangent, but hold on, I don't want to flip that. What should I flip instead? Flip that instead. So when I flip that, I get 2 roots of 10 over 3. Again, I'm just trying to show you ways to save time and try to refrain from making mistakes. Not too big of a deal, right? So let's do some application then. And so we're going to do 2 basic problems. You've maybe seen ones like this before in geometry. These problems would apply our learning. Again, a lot of times people might ask, when we use this in real life? You don't have to. You don't have to use anything in real life mathematics. You could be the guy who walks up and instead of giving the correct change, he just plops the, $10 in quarters and nickels and doesn't know how to count even change. He still gets by through life knowing no mathematics. Do I use this? Yeah. This summer I'm building a shed in my backyard, and when I figure out the pitch of the roof and what angles to cut everything, I'll be using this trigonometry. I use it at least on a yearly basis, if not more often. So here we go. Kite is flying at an angle of elevation of 36 degrees. So who wants to fly a kite? Okay, so we got Maddie out there. She's flying a kite. And flying at an angle of 36 degrees. And she has exactly, probably more like approximately, 500 feet of string that's let out. It's reasonable that you could calculate the angle of elevation. It's also reasonable that you would know how many feet is let out. It's not very reasonable that you would know the exact height of the kite. Anybody else thinking of the Mary Poppins song? My kids love that song. Yeah, they love it. So I'm going to call that y. We're wondering the height. Somebody choose a trigonometric ratio. Sine of 36 degrees is equal to y over 500. I will cross multiply and get y is equal to 500 sine of 36. And now I need a handy-dandy calculator because I don't know the exact value of sine of 36. If you do, you should not be taking this class. You're way too intelligent. 293.89. We're measuring in feet. There we have it. The second example is more how I will actually use, trigonometry in my projects. I will look at the rise and the run of, say, a set of stairs, or the rise and the run of a roof. And I'll figure out, boy, what angle do I need to make my cut so that I will get that perfect rise and run. So I'm very good at drawing trees. It's kind of one of my gifts. I have a tree, and it's 10 feet tall, and it says that it has a shadow of distance 7.3. So the question here is, I have a triangle. What is the angle of elevation of the sun to the horizon? So the horizon is out this direction. Sun is red, super hot. What is that angle of elevation? Okay. And again, my application might be the rise and the run of a set of stairs. So what angle do I need? So I'm looking for an angle here. Can somebody tell me which trig ratio do I set up? Tangent of theta is equal to what? Good, 10 over 7.3. So now this operation on my calculator, first of all, I'll make sure that I'm working in degrees. Right now it's in radians. And what I'll do is, instead of pressing tangent, I press second tangent. That doesn't mean tangent or 1 over tangent. It doesn't mean tangent to the negative 1. It means what we're doing is we're doing an inverse operation, which we'll get to later on. 10 divided by 7.3, I type that in, and it gives us the angle of 53.87 degrees. But that's useful information. It's valuable. You have your study guide. I'm slowly posting answer keys. The first thing I'm going to do is I'm going to put videos up online. I'm going to come around and start answering questions. I'll try to finish off the answer keys.